Hello and welcome to ARL Inside. I'm your host, TJ Gibson. The rise of fuel costs isn't missed on anyone in America, especially within the Department of Defense. As these costs seem to continue to mount and federal budgets shrink, the Army Research Laboratory is taking on an Army-wide project in surface engineering that the Defense Department hopes will ultimately improve automotive efficiency. The effort is called Surface Engineering for Propulsion and Transmission Energy Loss Reduction, or SEPTR, and it's looking at a wide range of basic and applied research areas to determine how much of a difference component surface treatments will drive down fuel costs and drive up engine performance.
At ARL, we were pretty excited to take this project on because, number one, we couldn't find one overarching organization that has done this before. Now, there's a lot of work in this type of area for obvious reasons with gas prices on the rise in the private sector and the commercial sector. So there is a lot of research going on, but there's no overarching organization that's compiling everything. So at ARL, we quickly agreed to do the project and immediately called TARDEC and got their support and started preparing our package and collaborating with TARDEC along the way to make sure that what we were doing was of interest to them because they're the primary beneficiaries of it. And as we've gone forward with that, we've also started collaborating with AMRDEC for the aviation side of things and what their interest is from an aviation perspective. This started out as a ground vehicle application because of the efficiency problems, of course, that our large military vehicles have in terms of fuel. But we're also looking at aviation-related applications for this. Where we really think the benefit is for aviation is in the military standard requirement for loss of lubrication in an aircraft. All military helicopters have a loss of lubrication requirement that they need to be able to operate for 30 minutes without any oil in the transmission so that the pilots can safely get from wherever they are back to a place that's about 30 minutes away if they have to.
To meet loss of lubrication requirement, ARL began looking at advanced materials, coatings, and treatments of gear surfaces to improve efficiency by reducing friction.
Because it's making it smoother, anytime there's friction in a surface, that's an energy loss. So friction will always cause your gas mileage to go down. It will always impact your fuel economy anytime you do it. So that's what takes away from your miles per gallon, basically, are those energy losses. And so if you can increase the efficiency of your drivetrain, then you're going to be able to go farther on a tank of gas.
They teamed with a group of experts here at Ohio State University, as well as within a number of military organizations, to investigate whether surface engineering techniques can yield tangible gains in power transfer efficiency within military vehicle drivetrains.
We are working with the ARL to develop studies with disc and roller specimen as well as gear specimen to determine loss of lube studies, wear characteristics, and friction coefficients between different types of steels, steel finishing techniques, as well as coatings within these different steels.
At Ohio State University's Gear Lab, which represents a consortium of industry gear users who require the state-of-the-art in advanced gear technology, researchers are executing research topics to characterize friction, wear, efficiency, loss of oil, and lubricant compatibility of different surface treatment techniques.
These techniques that we're doing determine loss of lube. So, for instance, if the ground vehicle were to lose all of its transmission fluid, for instance, how long would that transmission actually last within any sort of cycles? Is it going to fail as soon as it begins rotating, or is it going to actually start going X amount of distance and then it's going to fail? Or is it not going to fail at all? And that's what we're trying to understand as well.
Ohio State University is gaining that understanding with equipment like this that applies lubrication to specimen and analyzes outputs on an adjacent computer.
There's actually a flow meter outside the lube stand. We can measure very accurately how much lubrication is actually coming out of the nozzle itself.
All these gear systems are optimized for a certain configuration, for a certain geometry, for a certain type of oil application. So automotive gears work best in automotive oil. Aviation gears work best in aviation oil. So it's really kind of an overall optimized system. So as you start changing surface finish properties or you start adding coatings, you're changing that optimized system. So you have to look at not just the coating itself and how it operates. You have to operate, well, you have to think about how does that work with the kind of oil that we're using. So we have to do compatibility studies, and we also have to do with, if we're adding a coating to gears, we're increasing the thickness. These gears are optimized to turn together in a certain way. If we're changing the geometry, even just maybe a couple of thou of an inch, that could have an effect. And so we have to look at the whole package just to make sure that the system is optimized. If you have your fleet of Humvees, if you can increase the gas mileage, say, by 2.5 miles per gallon, there's a potential savings there of $21 million over a fleet of 150,000 vehicles. You have to realize that there's a cost incurred because you've got to do something different to the gears, so there's a cost incurred in putting these in your Humvee. But if you're saving money over the long run, if it's more affordable to do that, it may be in the Army's interest to start looking at these types of technologies, especially since the Army has been taking the lead on alternative energies, green technologies, and things like that, and that seems to be the national focus now. This could really have an impact.
OSU has one of the most respected gear research facilities in the country and is contributing to the SEPTA project through a cooperative research and development agreement with ARL. The SEPTA program provides the continuity the Army needs to evaluate different surface treatments with a standardized methodology. The project is funded by the Assistant Secretary of Defense for Research and Engineering.